when you start about thinking about, how do I make a radio that's the size of a few millimeters on the side, then you have to immediately think that there's no battery involved. I can't have a battery on this radio because that will be larger than my device. I can't have an external antenna. If you open up your wireless device, whether it's your cell phone or your laptop, you'll see there's a big antenna attached to it. There's a battery that's sitting right next to the radio, or there's some power supply. There's also a bunch of other stuff. So we couldn't have any of this. So we have to think about the radio design from grounds up, rethinking how you do synchronization, how do you do power up of the radio, all the way to how do you communicate with and from the radio, bidirectional link, without having any external antennas.
How did you make this work? How did you make this with no power, no antenna? What's the secret?
It's not that there's no power. There's obviously power, but we found a way of coupling enough power through the incoming signal to power up the radio. Now, powering up through wireless signals has been done before. It goes back to Tesla a long time ago. But our method is different in the sense that we use millimeter waves, very high frequency signals, to power up these radios. And when you use millimeter waves, the size of the device could actually go down to the size, to the dimensions we're actually looking for, to an ant size. So powering up through wireless devices has been done before. This is not the first time that's been done, but the trick is, if you use the right frequency and the right aperture size, and you go about it the right way, you can actually power very tiny devices at a reasonable range that's useful for many of these applications, and you can get away with very small power.
How close is this to being a commercial reality? Is this still something that's very much at an experimental stage?
If you think about what we published in the technical paper, that's ready to go. We have a chip now, it has a bidirectional link. That part is ready to go. But for many of the practical applications, you need another sensor to sit with the radio. So for example, you want a temperature sensor. Imagine you have a temperature sensor on a Band-Aid. The whole thing costs 5 cents. Everyone entering a hospital, you give them 5 of these Band-Aids, and the temperature, the body temperature of that person could be wirelessly communicated with the central unit in the hospital continuously. So that's one interesting application, and you can think about billions of these radios around. And for that, you need a temperature sensor to be built on the chip as well. So that needs a little bit more work. But what to keep in mind is temperature sensors on silicon chips have been done before. So for that part, we don't need to invent anything new. The hard part is, how do you communicate and work with something that's, a radio that's so small, and we've, I think, cracked the code on that part of the things.
It's a wonderful, or perhaps slightly scary, vision of the future that, all the things in the room around me could be talking to me, talking to each other, talking to the internet. Is this going to be the way forward, do you think, for our technological society? And are there any risks?
Moving into the future, a lot of the companies are now looking at an area called Internet of Things, where Internet, as I said, moves beyond your cell phones and into everyday objects. And that's already happening. We today have more connected devices than people on Earth. Now, are there risks? Yes, there are obviously risks involved. And I'm not an expert in privacy and security issues. But what to keep in mind is stopping technology advances for the purpose of avoiding risk and privacy, I don't think is going to work out, because sooner or later people will find out ways of coming up with different ways of connecting different devices. There are more positive outcomes of this, much more positive outcomes of this than negatives, and I think that's the way of the future.